Today we have a very intensive course actually, and we have a 6th part in this course. So first, what we should make today is generate a stained glass sketch using Stable Diffusion and Houdini using machine learning operators. Second point, we're going to open the created picture in TouchDesigner to process the sketch, create mask and image for tracing. Then we go back to Houdini and we'll generate the high resolution 3D model in Houdini. Then we set up rendering and compositing in TouchDesigner, and then we proceed with interactive part. First point, I will not go too deep now into setup of machine learning operators. Basically, you can just download them, and most important part is to go to your user documents. Then you have to find the Houdini 20, in my case, folder, and in this folder you will see the packages where you can put the machine learning operators JSON file. And if I open that, basically I just need to set up the proper folder. So in my case, everything installed in my working folder on Harddrive, work, GitHub, machine learning operators. So I can set the main variable to that folder, and then all other directories I set it up correctly related to this $MLOps. And next step, we want to know how actually the guys from Entagma integrated Stable Diffusion into Houdini, how the data flow is designed. And first I want to show some small diagram. That's a very cool article I found on internet where the basic concept of Stable Diffusion is quite well written. So basically we have several steps. First step is prompting, and prompt is actually the text. But in order to work with the model, it should be converted to tokens. Tokens are integer variables or integers which are converted from text to the tokens by the clip model. It's special stage. We will provide all links after the workshop. So basically I have to announce that we go very fast. So basically I record everything in high quality from my screen, not from stream, and then we will upload the recordings and send you documentation with all working files. So now you can just relax and look into monitor and try to follow my explanation, and then you will have all working files and links to download everything, so you can work later on it on yourself. So basically then the next stage is a prediction which generate the image in the latent space, and then last step is VIA encoder, decoder, which converts it to the image space. So basically that is a basic understanding how everything is working. I will also post that link to you. I will post it now to Discord. And let's continue. So if we go into Houdini, we first need to create a geometry object. The machine learning operators are existing in different Houdini contexts. So, but main work happens, at least in our case, main work happens in the SOAP context. So in order to deal with that, we need to dive inside of geometry, and then in machine learning operators in submenu we can find a bunch of tools what we have. So what we need as a first, we need to create the SD prompt And let's look what data is created by this operator. That is very interesting. If we go to the geometry spreadsheet, we will find that that operator, which has only one parameter, which is prompt, will generate one point with two attributes. One basic attribute is a P, which is a point position, and the second attribute is a textual string attribute called prompt. There the prompt is saved. Okay, then in order to work with this data, we should create a SD tokenizer. And then we just connect that. And here some magic starts to happen. Basically, from the theory of working with Stable Diffusion, we should know that token is a 77-dimensional vector, or other words, is an integer array containing 77 values. And Clip model tried to find the latent value corresponding to the words we describing. So that is basically the first level of translation from the human language to the machine language. And in Houdini it's realized as a 77 points, which are all positioned in the 0, 0, 0, which all have still the same text parameter, prompt, but they also have a token variable or token attribute. So basically we can see that only first 11 values are meaningful. Everything else is just a repeating of the last value. As soon as I know in Stable Diffusion, it always token is always created as a variable of the 77 values, but only first values are used if it's not so long prompt. In that case, we need basically two prompts, one prompt and one unprompt. So we can copy and paste that. So let's call it unprompt. And then let's just follow the main setup. Next thing what we need is to create a textual embedding. That is done by using the SD text encoder. And that operator takes two inputs, one for positive prompt and one for negative prompt. So we connect both things here. And as a result, we will receive the float vector, unconditional embedding and unconditional embedding pooled. So basically that is the resulting value which is sent to the scheduler and to the sampler, and which is basically processing the data from the latent database, which is a model. I used for my example all default models, so I don't need to download something special. Next step, we should create a scheduler. Okay. And that operator do the main work. Here we can set up all the basic parameters like width and height, number of steps, SFG scale, guide image deviation, seed, scheduler type. And I will show now what parameters I was using for my example. And now we need to connect the Stable Diffusion solver, which actually will do the full work. And here you can see that actually something happens. If I zoom my screen, for that I can always in Houdini, if I enter my mouse into the viewport, I press spacebar and then I can click H for home. You can see that actually the image, the resulting image is represented by the points, and that's what is returned. We didn't edit the prompt, so it has just a default prompt saved in the node, in the operator, so the image is completely random. And what is interesting, then if I change the seed, the image will be regenerated, and it looks even more strange, but doesn't matter. We will need also the next stage. We need to export this image to the hard drive, and then we basically can continue to the setup what we need to achieve. We can also use the one second. There is a special operator for upscaling, real as gran, press. And that will generate quite huge image. So let's reduce the size for upscale factor 2. Okay, that way we set it up the basic pipeline of text to image. So we need to create the export image, and I will select all operators and create the network box by clicking this button, so we can easily visually recognize that it's a full working block. Before I go to the edit of the prompt, I want to show also something which I found today in the morning preparing to the masterclass, that machine learning operators provide also very interesting tool which can convert the image to the prompt, so you can use it to learn how to prompt. For that we need to use a special operator which is called image to points. So basically it's a tool which takes an image from the drive. So let me make a save our project, then I go to the Dropbox, Creative Code Art, new folder, I will call it work, and here we will set up our work. So generate heap. Then I just downloaded some image from the internet, just looking for something which is looks like a stained glass. So let me open my working folder. That's quite easy image. I just want to analyze what the tool provided by the MLOps will return from that image. So I can take this image. It will generate corresponding amount of points and color that points with the color of the image. So basically every point, every geometrical point corresponds to the pixel of the image. And then I can bring the operator which you can find in MLOps menu, text, and MLOP clip interrogate. So that thing do the opposite operation. That thing will convert that image to text. It can take a while, and then if I go to the geometry spreadsheet, I will find that clip interrogate just generated the same result like SD prompt create. It generates one point with a prompt. So it's written something more interesting than just a high quality image. A close-up of stained glass window with cross in the center, 2D vector, logo, blah blah blah. So I tried to use that as a prompt. So theoretically I just can connect that instead of SD prompt create now. And let's look what happens after the SD solver. That looks funny, not precisely what we want, but already something more than before. Also very cool thing that we can set up the seed as expression related to the current frame. For that we can use the H script variable. Houdini has basically 3 languages, and one of these languages is H script. It's very old school. It's similar to the language what every Unix system has as a bash script language. But yeah, okay, important to understand that that language contains a bunch of so-called local variables, and that variables always start with a $sign. So I just can write here $f, and that will return the link to the current frame. That way I can just regenerate the image switching the frame. So I don't need to change the seed parameter myself. Then we can test what happens if we increase the amount of steps. It will logically a bit slower. Then we can test what SFG scale do. Basically we can define this parameter from 0 to 10 as how much that image is close to the prompt. More value we put into this parameter, more close it should be to the prompt. So we can make 9. We can go to something small and see what happens there. So it makes very abstract art, which is even looks funny, but not for our case. For guide image deviation, we don't have any guide image. For that reason, actually it's not important right now, but just in order you know, we have 2 additional inputs on this SD scheduler, and if we bring the mouse here, we can see the image input in case we want to make image to image, and we have a mask input in case we want to use the mask. Okay, now I will just show what was working for me. I don't want to spend all 3 hours diving into prompt engineering. That is not the topic of our course right now. So I switch back to the SD prompt create, and then I just will enter the values I was using on my tests. So on SD prompt create, I will put the illustrator, I will put the round stained glass window, with 1 peacock. Beautiful. flowers, black contour, art deco, bright flat colors, high contrast. Okay, don't care if I don't answer all your questions right now, so I will make breaks where I will go through the questions. Otherwise we will have too much chaos. Okay, on the unprompt I will also edit something. Traditionally I don't want the ugly image, I don't want mangled, bad, disfigured, cheap. I don't want to have watermark, and I want not to have the dark colors. So basically what we need to generate the very contrast image, because otherwise we will need to make the handwork, what is basically what we want to avoid during our workshop, because we are speaking about the procedural graphics. Yeah, so procedural graphics is all done by functions or by operators, by nodes. So we don't want really to make some kind of Photoshop work. Then I was using for my example, which was announced on our promotion company, the DDPM scheduler. So let's try to make 7.5 by default. Oh, it looks interesting. Something completely different what I was making before. Okay, that is closer. However, I don't really see here any peacock. But okay, that actually doesn't matter so much right now. So that's all the creative part you can do yourself, achieving that nice image you want. Most important that we made some image by the Stable Diffusion. Regarding the technical questions, which can be if you use CUDA or completely CPU, you have to check the parameters of the operators, and you can find on the text encoder that you can use CUDA, CPU, MPS, and I think on solver you also have the same parameter. Also, if you want to use LoRa's, you have a special parameter for that. Now I landed to the part where we can export the image on the hard drive and continue to work with that image in TouchDesigner. Basically, I chosen this example especially because I wanted to showcase the real pipeline of a small project where different programs are involved, and I was looking for a kind of example where we really need both Houdini and TouchDesigner. Also, logically, in order to generate that image, you could use Automatic 111, custom setups, Comfy UI, Stable Diffusion in TouchDesigner, but I found that example of machine learning operators is a very practical and handy tool, because in that tool set you can find a bunch of very cool instruments which can make, for example, the custom models. So you can train your own custom models very fast and easy. For example, in case you want 100% avoid using the models trained on some kind of copyrighted data, or you want to train model for a very particular case. Okay, next thing, we can generate the we can save the image. How to interpret that parameter: $hip/out/$os/$f.png. Again, TouchDesigner as well as Houdini as well as TouchDesigner using a lot of expressions in parameters, and all these expressions can be written either on Python or on HScript or on Vex in particular cases in Houdini. I will explain later what does it mean, but for now, just to understand, to make all paths relative to where the project is saved in, Houdini intensively use these local variables where $HIP or $hip means the folder where the current project is saved. So that way all other paths are relative to this folder. So that string means that in folder where the current project saved in, it will be generated a new folder called out, and there it will be generated a PNG file which will be automatically named on following pattern. $OS means the name of this operator. $F, like before, means current frame. So let's just rename it to, or we can basically, working on Houdini wise, rename the expert image to the sketch, and then we click on export. We will find that the out folder is generated, and we have the sketch which has a size 1024 by 1024 because we were using the upscaler. Okay, now I will name this geometry object as D and disable its visibility. Save project again and open TouchDesigner. Before or during I open TouchDesigner, I could tell actually that we could use the HOU2 network. Yeah, that is actually HOU2 network, and it's where the TouchDesigner was born. Because in this context, we can work with images. So I can create open composite viewer. I can make a file in, load this image we just generated, and work with it. The thing is that compositing context in Houdini is powerful but very slow. So for our workshop, that doesn't make any sense because we have TouchDesigner, and TouchDesigner can process all images in real time, which makes sense. Okay, now I will also save the TouchDesigner project, file save as, and go directly to the Creative Code artwork and call it process image. Then I can just go to out and drag and drop my image into TouchDesigner. So I have the I loaded the image, and here we can do some color correction. So for example, I can use NVIDIA denoiser. So important thing about all operators in TouchDesigner which are starting with NVIDIA in the name logically works only on NVIDIA. That's unfortunately bad news for the Mac users, but everything else in most of cases works in all platforms. Just some operators are related to the NVIDIA technology, so they cannot work on the Mac or even on Windows with the other graphic cards than NVIDIA. Okay, then I can use upscaler here again to make it 2K actually. Okay, what I want to achieve? I want to have two images. One image should be just a color image, which I will use for the texturing, and second image should be like a mask, black and white image. And here I can do several corrections. First, I want to use the open color AO. That is a very powerful color corrector. Here I go to the CDL transform where I can change values, and then I can try to correct it. So basically I want to make it so contrast than possible. I can work on the colors. I can try to remove the red color by using the change color. So here in palette we have the image filters, and here we can find some very practical tools like change to color, for example. Then I'm going to find the red color, and then I will try to make it more blue. Then I want also to make delayed erode, which I also can find here as a delayed operator in palette. And I will reduce the kernel size to 5, so to make the better contour. Then I'm going to create a monochrome operator, and I can check in which colors it looks better. So basically if I use the green color, it looks quite nice. So we're losing some details here, but okay. Now I can create again the another delayed and put it in erode mode and do the opposite operation with 5 pixels. Then using threshold I can generate a black and white mask. I will put alpha in 1, so I have a black and white image. And theoretically I can process it a bit using the edge operator. If I set the edge color to black, and then I will comb over input, that way I can increase a bit the width of the contours if I want, and then I can also control it by the black level, by the strength, and if I reduce the sample size, I will actually reduce the how thin my line is. Okay, and on the end I can use the level operator for inversion. So basically I just need a black and white image which I can use as a mask. Okay, I finished the part of the example, and I will answer to the last question I see in chat right now. How difficulty, then even someone who doesn't know Houdini. Basically, Houdini is not that complicated. Because of that, we started this online masterclass just to showcase how I solve the problem, what I put in the start of the lesson, and you can see the basic working tools and understand the procedural logic of creation. Logically, in order to can do something powerful with Houdini, you need experience, but first thing you need to achieve to not to have fear to learn it, and that is a task for our today course. What I want to give to you to remove the fear of learning Houdini and TouchDesigner. So using Alt and left mouse button, I can create nice network box or annotation box in TouchDesigner. And on the end I have, let me create another operator. I can just use a file, movie file out, for writing this file back to the hard drive. And I set it to image, I set it, let it be OpenXR, let's call it here to the mask, and let's put the folder in front. So I will just make a new folder in our working project and call it new folder big T for textures. So I will put T/mask and then me.file suffix which will automatically generate the proper name. And now I can click on record, unclick the record, and image is saved. That is a mask XR. And then I can make a second movie file out, just copy and paste. And here I will change the name to color and also record it. Then I save this project and I can close TouchDesigner for a while. Okay, voila, we just managed to make briefly overview of two first points of our lesson. I will check for questions in Discord. So, okay, actually we just created a Discord chat as a backup in case of technical problems, because I had once a situation when occasionally YouTube finished the streaming and we could not even announce the new point for streaming for anyone. But I reading also the questions on the YouTube, so you can use both chat for asking the questions. I see the question of Patrick Matz is very specific reason why you are running SD in Houdini instead of TouchDesigner. Just because I wanted to show that example, and also in TouchDesigner still there are no good pipeline integrations. So we are making our own custom integration with Vadim Epstein, with whom we're doing the machine learning course on our portal. But it's kind of very better now. All other versions what we have now are not that integrations at all. They're using the external servers, either automatic or Comfy UI. So basically that's nothing to tell about. And machine learning operators is a very cool tool where you can analyze the data flow, how the data between different steps of Stable Diffusion pipeline is flowing. And that's the reason why I choose that way. Because of that, we can easily understand what is happens inside of Stable Diffusion. So that's, for me currently in this course, was more interesting than the performance. Okay, now I turn back to the scene view, and we can slowly go to the tracing part. I will generate a new geometry object in Houdini and call it stained glass. And here we will see how to work with procedural modeling in Houdini. So this is my favorite part here. Okay, in order to convert image to the lines, to the geometry, we need to create the trace SOP. SOP means surface operator. So basically, for people who are very fresh to either Houdini or TouchDesigner or both, I can just explain that both programs were created by the same people in some moment. Then these two programs just went as two branches in different directions, but basically the concept is quite the same. And that's why I also teach both Houdini and TouchDesigner, because they add their powerful points to merge it in the very nice pipeline, solving any possible tasks. And okay, what are these strange names? SOPs, CHOPs, TOPs, POPs, etc. OP is for OP, is for operator, and first letter is for the type of operator. Basically, everything what we do in both TouchDesigner and Houdini, we are processing data. And every data is represented as array of data, yeah? Because if we work with geometry, we can imagine that every geometry is typically an array of points. If you're processing image, then we can imagine that image is array of pixels. And CHOP is an array of just digital float values. Even sound on the end is just amount of samples representing the sound wave. And in both Houdini and TouchDesigner, in most of cases, the similar names of the family of operators are used. In Houdini, the workflow between these families, or how it's called here, context of operation, is very strict. So we cannot create in the same context the operators of different type, but there are managers for that. But anyway, in TouchDesigner you can use in the same context different families of operators, which makes the work a bit faster and easier, and sometimes more chaotic. Anyway, the workflow is quite similar. Even if we compare the basic user interface, yeah, we can find that it looks quite similar. Yeah, Houdini and TouchDesigner all have the same parts and same elements in design. So by default, we have only network viewer in TouchDesigner, but we can split left-right, and we can easily open here the geometry viewer. And in that case, you can easily find the similarity between Houdini and TouchDesigner. So because it has a geometry viewer, it has network viewer, it has parameter editor. Here the parameter editor is put in a separate window, but basically you can do it also in TouchDesigner if you want. Okay, so we are on first opening Houdini, we are always landing to the object context. Object context is a 3D world. It's where we create all our objects, yeah? Like if I sit in my studio right now, I have a monitor, I have synthesizer, I have chairs, tables, and I have camera which is filming me and sending to you in the stream. So basically the same ideas in the object context. Here we can create cameras, we can create lights, we can create geometry objects, and a lot of additional special objects which can be seen as utilities. But the object itself doesn't have any information about how it's constructed. And in order to deal with that, we need actually dive inside of that object and generate for its topology. What is the content? Yeah, we have attached the content to the idea of this object positioned in the space. Yeah, I see a nice comment about the pops coming in TouchDesigner for the first time will be naming mismatch with Houdini. That is not completely true, because in Houdini we have tops, which means completely different thing than tops in TouchDesigner since a while. So it's second time. Okay, trace. After that's like theoretical comments, I will continue to work on our thing. So in trace we have two options how we can load the content of the image. We can use for that a direct link to the hard drive, or we can use a cop operator from the cop context. I go with the first option. Just will load this T folder with the mask. And as you can see, some geometry is generated. If I click with middle mouse button on the object, we can see the technical information about the state of data in this operator. That's important to understand. So we see the full construction. We see how much points were created, how much primitives are created, how much vertices are created, and what the types of these primitives. So basically, we can also check the primitive numbers. I think in all of this geometry we have one big polygon which we need to delete. And sometimes we can see that some pieces are maybe too small or too big. In order to clean up the result of generation, I will make first some settings in the trace operator. I will remove borders. That will remove this big polygon around. I will smooth shapes and reduce a bit the corner delta. I will change fit to curves which will convert the geometry to Bezier curves instead of polygons. And then I convert to polygon again and reduce a bit the level of detail. Then in trace parameters, we can play with a trace threshold, which is a black and white value there where trace is actually happens. And yeah, I think we are done with that, so I can continue to measure the geometry. And what I want to show as well is that we can use a measure operator. That's a super practical tool. It has this sign on the icon, and using this operator we can generate the technical attributes which can provide different information about input input geometry. For example, I don't know if I want to really fit it to curves or not. I think I'd avoid that step. I also check what is maybe I turn back the last project. I want to increase the size of border a bit because I'm losing some geometry. And yeah, here basically it's my predefined example. I was using the recent. Okay, let me open that project we're doing right now. And I will open that project. Open with TouchDesigner 2023. And here, maybe before denoiser or after denoiser, or even after upscaler. Okay, here, after upscaler, I will put the transform operator, and then I will reconnect everything. And here I will make the background color black and scale the full thing a bit down. That way I can avoid cutting of these polygons. And now I just select both movie file outs and record again. So now I can turn back to Houdini, and in trace I can reload image, and voila, here was a hole in polygons. Now it's solved. Okay, now I can use a measure tool to measure the area of primitives. What does it mean? That operator go in a loop automatically through all polygons and measure its area, and it should save the area somewhere. You have to understand the thing that geometry is not just a geometry. Geometry is data, and in data we need some kind of holders of this data to save the data of different type. So that thing is called in Houdini and in TouchDesigner geometric attributes, and that we can see in Houdini using geometry spreadsheet. It decided to generate the prompt again because it's where we were last time opened the geometry spreadsheet. I think I have this it's a moment where I need to restart Houdini because it's frozen. So I will shortly reproduce what I've done before. So I create a geometry object. I go inside, create a trace. Then I will load this mask. And I will remove borders. Using this button we can see how much points we have. So I can reduce a bit the complexity of geometry by changing the step size. And let's create the, I don't know if I really want to use these smooth shapes or not. No, I will not use it. So then what I want to make now, I want to delete two small polygons. That's why I was making the measure operator. And I wanted to show you there the data is saved. For that we should go to geometry spreadsheet. And here in geometry spreadsheet we can see 4 buttons on the top where we can select what kind of data we want to visualize. If we want to see the point attributes, if we want to see the vertex attributes, if we want to see the primitives attributes, and if we want to see the detail attributes. So for now we want to see the area, which is a primitive attribute, because area don't need to be saved for every point. So in order to reduce the amount of data we're dealing with, it's saved for every primitive or for every part of geometry. And here we can check. There are some primitives which have very small area values and some primitives which are relatively big. So, and now we can actually do the following thing. We can create a group. And in this group we can generate a primitive group, call it small, and make the group it's old school way, group expression that we can do. So it will be a primitive group called small, and here we can write an expression. In order to reference to the attribute, we use at for attribute and the name of attribute, which is area. And then we write a rule: if area is less than 0.0001. And now with a small mouse button, with middle mouse button, we can check that primitive group called small contains 12 primitives. And in next step, we can use delete operator to delete all primitives which are small. Now I showed the very important concept, what you have to understand to really feel the power of procedural workflow. That expression will automatically put in the named selection list or group all primitives, doesn't matter which geometry comes on input. So if you will generate 200 versions of this sketch, all of them will be processed on the same algorithm. And what is cool, that selection will be saved, so you can not only use it in the next operator, you can use it anywhere downstairs. So after the moment you created that group. So now this group is not existing anymore because we deleted all these primitives. But if I would not delete, for example, I could put a color and I can make two color operators, and first color operator I put a, let's make a primitive color white, and second operator I will put it in primitive color red, and then I can name can use that only for the small primitives. Maybe it's also good to visualize, because maybe those primitives are too small. I missed the order, so basically I needed to make it in opposite way. So first I create a primitive color white, and then I do the primitive color red, and you can see these small primitives which are deleted. And we can use that to analyze if we deleted all primitives we wanted, or we want to increase that range. And then I can delete still by the same name, by the small. Okay, now we have a final geometry. I will turn back to TouchDesigner, and actually what I want to make, I want to make a second mask for the metal part. I think I will just create the circle connected to the geometry. Let's make it for now red so we can see it. Should be a bit smaller than 0.5. Now we can go to the output on circle, and let's make the multiply. Let's make it white. And I think we need to make it before the inversion. And let's put it on the, okay, maybe I just do it here. Yeah, then I can invert it again, level, and invert. So then I make a third mask for the metal part, mask 2, and I will record it. So then I can, actually what I can do now, I can collapse all of this network together. I select all of these operators. So let me make a null on the end. And now I select all of these operators and use that button, create subnetwork from selected. So I actually made all operators to be one operator. Now I can copy and paste these two operators, and I just will change the image to mask 2. And I think I don't need to remove borders. I think there is a one super big polygon, so I can actually go inside now and check the measure for the sizes. So yeah, we have one polygon which is super big. So now I will just delete that primitive, actually it's primitive number 0. So I will make another delete operator and delete the primitive by number. Okay, we have again the same thing. Okay, we can create it actually different way. So now we have a basis for future work, and using this geometry we can generate a glass geometry. So let's save the project. Okay, next step, I want to make these primitives to be thick. For that I go to use the PolyExtrude. And if I select this operator, I can visualize the manipulators, so which can give me the possibility to visually edit the geometry in viewport. That is here, so you can achieve it by pressing the enter button or clicking on the show handle tool. And now you can see we have a manipulator which I can just move, and as you can see I will create that way the extruded geometry. I don't want to make it super thick, I just make it 0.07 or 8, and as you can see it's extruding and backside is missing. If we go to the parameters, we can find that here we can output different parts of the extrusion process. So I just need to click on output back. That way I will create the closed geometry. And what I want to make with this geometry. This geometry has a bit crazy topology, and if I will try to smooth that border to make this thing looking like a glass, I will break my head to find a way how to analyze the logic of this geometry, because it's one big polygon. So what I want to make, I want to rasterize this geometry into voxels. Voxels are volumetric pixels. So basically, if I open a paint, you can imagine that typical image is just amount of small pixels. So basically, if we just split the image by horizontal and vertical lines, sorry for the quality of drawing, we will generate these pixels. If we do completely the same in volume, so we will split that by the division and add a third dimension to that image, we will have a boxes which contains data. That is called voxels, or which is a shortcut for volumetric pixels. And in Houdini we have different versions how to deal with voxels. And one of the coolest way is the integration of VDB surfaces. I will not dive now too much in what does it mean. It's actually a way of dealing with volumetric data which is quite cool, optimized, and because of that it's fast. So we can just create the special operator called VDB from polygons. Only thing it need to have a closed geometry. So VDB from polygons, and that looks now quite strange, yeah, because the resolution of voxel size is very big. So we're dealing with much smaller digits. And I go and make the size of voxel less than the depth of extrusion. 001. Now it takes a while, and then we have a volumetric representation of this geometry. So that's a so-called signed distance field. So that's a geometry existing from the voxels. And we can now do some operation with that. What I want to make here, I want to smooth that a bit to make more nicer surface. I will make a smooth. I need to have to make the VDB smooth, and that makes the geometry looking much nicer. It has now too much of iterations, so I will reduce a bit, 1 or 2 iterations, and I think it's quite cool. What I want to make else, I want to generate a metal part, because I could not trace the geometry. I can do the intersection. So what I want to make for that, before the VDB smooth, where I have that VDB from polygons, I will generate the tube. I will point this tube to that direction, make it using spacebar 1, 2, 3, 4. We can switch between different viewports. So I go now to the front of viewport, and I will increase the details of my tube. Then I go to the vertical, to the top view, and I will change the height 0.005, and also I will move it center by Z, so that it completely intersects with my geometry. Then maybe even I will make it 6. That looks cool. So now I will copy and paste VDB from polygons and connect the VDB from polygons to the tube out. So now I have the second VDB geometry. Okay, now that tube should have caps, so I will enable end caps, and then I will see the tube created from the VDB. Maybe I will even increase the amount of columns to 100 to make it very smooth. And now I can make the VDB intersect, which is kind of boolean for the volumetric things. VDB is SDF intersect. or even subtract. I think I can put it on the right side. VDB SDF subtract. So I will subtract from the tube, I will subtract the glasses. So now I have the metal part. And I can process that metal part separately. Just I want to make it before the smoothing. And I copy and paste the smooth here as well. Okay, let me save the project. We have the both geometry of frame and geometry of glass pieces. And it's kind of almost a half of our workshop. Do you have some questions? Anyone super tired, exploded brains? Tell me something. Let's keep in touch during the lesson. Okay, I go forward and I will convert it back to polygons. For that I need to use the operator called convert VDB, which is sound logical. And let's convert it to the polygons using the button here on the right top part of the viewport. We can see different visualization types. So I will use the flat wire shaded, and that way we can see how the resulting geometry is looking like. I want logically to optimize it a bit because it's too detailed, and for that I can use the PolyReduce operator. Here I can choose different algorithms. One of algorithms is use the percentage of input polygon count, and I will set it to around 50%, which will take a while to process. Maybe I a bit overdone. Let's make something like 70. I think it looks quite okay for the real-time visualization. We have now 730, maybe. Okay, let's try to optimize it again a bit. So now we have 500,000. That will be the frame. Then if I switch to the smooth shaded, I might need to generate the proper normals. For that I can use a facet operator. And here I just need to click post compute normals. Okay, on the second side I will do something very similar, and I will make the convert to VDB, convert VDB to polygons, sorry, and make a polygons. We can do a bit of interesting magic with these things, because now we don't need so much density in our geometry to have just a flat glasses. So I want to maybe to make it looking more interesting. What I can do here, just as a basic example, I will do following thing. I want to add a bit of noise on the surface. And first what I want to make, I want somehow to separate that part of geometry which is on borders from the geometry which is inside of the glass. How I can make this? I can use for that kind of analysis. So I can use the PolyExtrude. If I enable on the PolyExtrude the groups, remember a half an hour ago I was using the groups to programmatically save the primitives which have a small area. Now I can create the groups on the different algorithm. And because PolyExtrusion itself knows how which polygons belongs to each part of the extrusion process, it can automatically generate groups if we want it. So basically I can generate a side group, and then I can delete that side group, delete everything else than side group. So if I do that now, I just choose extrude side and I will tell delete non-selected. So I have the sides of the geometry, and then I can use that geometry of the sides of extrusion to analyze which points from the glass are closer to these sides. How I can make it on the best way? I can use the special operator called attributes transfer, which takes every point and measure the distance between its point and geometry on the other input, and it can radiate the value, some kind of value. So I can visualize it very easy, but I will need more detailed geometry here, because otherwise I only have points which are too far from each other. So I will make the remesh operator to bring that in more random and detailed okay, it needs some time, I think. I can just block because it's obviously want to go too slow. If I want to interrupt the operation, I can just use the escape button. I will just use a subdivide, and then I will subdivide it several times, so I have more dense grid. And now I will put for visualization I will just use color. So I will color points by black on one side and color other geometry to white, and then I can use the attribute transfer. Important information for beginners: the main geometry you want to process is always connected on the left side in Houdini. In TouchDesigner it's always connected to the upper input. So I connected here, and the additional geometry to transfer the attributes from should be connected on the second side. And now we see the full geometry became white again. That's we don't want. First I have to select the attribute which is color, which I want to transfer, and then we go to the conditions. In that conditions we can see that there is a distance threshold. So if I try to remove the distance threshold and will start to increase it by the small distance, you will see that the sides are colored by white and the rest is colored by black. And I want to have the smoothness. For that I can use the blend width. So I will add the blend width, and now you see the smooth blend between white and black. Now I will just change the order, because I want to use that color also for power of the operation. What I want to make now is next. I want to push these points a bit inside and add a bit of noise. In order to push inside, push point inside, I can use the pick operator. And here I just can use distance. Pick operator works on normals, so every point has normals, and it will push the point position based on the normal direction. So I will just push it a bit smaller, something like that. And in order to generate something more interesting and to make it very controllable, I want to introduce you the VEX operations. VEX is originally was a shading language similar to GLSL, and it was designed to make the shaders in Houdini. But then side effects team realized that it's super efficient language for geometry processing, so they bring that language everywhere, and now we can create the VEX code for geometry. And what is even more interesting, that in Houdini we have a VOP. VOP is VEX operator, or other words, is a possibility to program that language visually by operators. So I just create the point VOP. I will connect the both geometries to the first and second input and dive inside. And what we see here is the actually something which corresponds to the code. On one hand, we see all geometric VOP global attributes. That's the position, velocity, force, age, life, ID, number of a point, color, UV coordinate, normal, and even we have a global things like time frame, etc. And that way we can access the data coming to the first input. But we push geometry inside. Basically, we can access it using the import point attribute. Then we select the P attribute. Instead of file, we choose a second input, and as a result, we have the position of point after that peak coming to the second input. And now we can use a mix and mix positions just on one thing, that CD or color is returned as a vector, and for bias we need to use a float. So all three parts of the color contains the same value, so basically we need just to separate vector to float. So we use vector to float, vector free, vector to float. We connect it to the CD, and then we use any value of here to the bias, and then we can connect the first input and second input and output the result to the P position. So basically you can see now that we pushed points inside based on this CD attribute, and then we can easily control that shape by the attribute transfer, controlling the blend width. And then inside, in the white part, we want also to add a bit of noise displacement. So that's white part is what we have actually on the, let's make it, align it like that. That's what we have here between the mix and the first that we have on the second input, yeah, what we have here. So we can capture the, we can generate the noise by any of the noise function, and in Houdini we have a bunch of these noise functions. So let's make any of them, like, okay, let's take just anti-aliased noise. It needs some position on input, and also then we need to have the normals. So basically it doesn't make so much of matter right now. We can choose the normal from the first input, and we multiply noise by the normal and add to original position. So we use multiply here, we choose the normal, multiply it by noise, and then we take the position from the second input and add noise displacement to its position and provide it here. Okay, now we have too much of noise. Logically, we don't want to see so much of noise right now. It looks it looks crazy actually, but it's too much. So in order to be able to process all of that, we need actually, don't want to go anytime inside of this operator. So basically we can promote these parameters of noise to the upper level. And for that we can either click with middle mouse button on the parameter input and say promote parameter, or we can click with right mouse button on the noise itself, and we can tell here in VEX options, create input parameters. It will generate all input parameters. Let's save the project. I will answer now to the question of Mattia. Sure, we will provide all projects after the class by the mail. I created the parameters for the point VOP. So now if I scroll the parameter editor, after I exited back to the geometry context, we can see that all parameters. I will logically reduce the amplitude. Let's make it first a bit bigger so we can see. And I want to have to change the frequency, because I want to have more details. So I will increase the frequency, and then I will reduce the amplitude by something small. And now I can create the normals. First I'm going to delete the color attribute because we don't need that. So I will use attribute delete, and I will delete the point color attribute, and then I will create the normals by using facet SOP, and here I just post compute normals, and we see that our geometry looks much more interesting and detailed than it was before. So it looks really like a glass, because stained glass is never completely flat. Okay, next thing what we need here, okay, we have to double check in some points that maybe was too much of displacement, but because it's all procedural, we can always correct it. So let's make it 0.5. Let's increase the frequency even more and decrease the amplitude. Now it looks much better. Okay, next thing, I think we also, before converting, so we have that glass, that metal thing. I think I need to scale it a bit. VTB. We have something like transform here. I think I just make a transform. Let me jam a bit. I will just move that in front. Then I will use the VDB SDF union to union both parts. So that way I achieved the more width of my metal part, and then I convert. Then I PolyReduce. Then I facet. Then I will align everything a bit more structured way and use the network box to make it looking more designed and understandable. Because order is a key to understand what we done later. So that will be the frame, metal frame. And we can color it by black. And that will be the glass. Also later, we will need to be able to separate that geometrical pieces by some attribute, because we're going to make music with that on the end. And I think I will need to make several things. I want to give a UV to my glass geometry. So I will make the UV project. For example. And then here in viewport there is also a special UV view. So if I go to the persp menu, I will find that I can see the different viewports and I can see the UV viewport. And here, if I click on D, I will open the display options. In Houdini, always you can relate the hotkeys to the name of what you are doing. And here I will bring the color . Okay, it's not really visible here. can change the background here. So I go and will go to heap, find my color, and then using the parameters on UV project, I can play a bit with the scale of my texture to adjust it to the texture. I think I just needed to scale it a bit down, and I have a proper UV now. Then I click spacebar 1 to turn back to the viewport. Then we can use the UV quick shade parameter object to visualize the texture. And here we can bring the proper texture map, so we can see that everything is correctly shaded. So let me save the project again. And last thing, before I export the geometry, I want to make the unique IDs for every geometry. And I want to have this attribute as a float, because TouchDesigner needs float. So how I can generate the unique ID for every point which belongs to one geometrical shell, to the one geometrical piece. For that, in Houdini we have the special operator called connectivity. And connectivity can generate a class attribute based on the connection. So if we go now to the geometrical spreadsheet and switch back to points, we can see that we have a class attribute, and there are a bunch of points which have different class attribute. So I cannot unfortunately here directly switch from integer to float, so I have to make it myself. And for that I go to create and show you also the second way how we can deal with vex. Instead of creating the VOP operator, you can create a special operator called attribute wrangle or point wrangle, which is basically the same. Let me make a wrangle and point wrangle. And here we can do completely the same what we can do with point VOP, but using code. And only thing I want to create a new attribute of float type, which I can do by typing F. Then I will make add for making Houdini understand that I'm creating the attribute. Then I will write the name of attribute, which will be ID. Then I write equal. Oops. And then I say that I want to convert the original class attribute, which was integer, to the float. So I do float, round parentheses, and write add class, and close it by the semicolon. So now I have a new ID attribute, which is completely corresponds to the class, but it has float dimension. And that's basically all on that part. So we have a final geometry. And what I want to make now, I want to export this geometry to TouchDesigner. For that we can use ROP. ROP in Houdini means render outputs, and that's our special operators for the render operation or for saving on the hard drive. But there are also special shortcuts, so we can basically create a ROP network, dive inside, and we output context. But in order to simplify things, we have also ROP geometry output operator, And we can use different formats to transfer data to TouchDesigner. We can use Alembic. We can use one format which is supported both by Houdini and TouchDesigner, and that format is called BH Classic. So now we have to define the names. So that will be the, let's call that operator metal frame out. We don't need the heap name here. We don't need $frame. And we rename it from BGeo to BH Classic. Then I copy and paste that operator to here, and we'll rename it to the glass out. Glass out. And then in order to save, I just have to click on the Save to Disk button, and also here I have to save to disk. So now in the work folder we will have Geo folder where we have 2 geometries. And it's time to open TouchDesigner. So we will save that process folder, and I will create a new project. We continue with the part where we're going to set up the render. Yes, it's TouchDesigner time finally. In order to go a bit faster, I open in a second monitor the ready project so I don't forget anything, but basically I will, like before, continue doing that from scratch. BH Classic and Alembic logically have a bunch of differences, but BH Classic is a format which completely save all data of Houdini to TouchDesigner with all metadata like attributes and group supported by both programs. I think for saving static frames, for my taste, BH Classic is a best choice. But you can use Alembic because Alembic can also support some of Houdini attributes. Okay. So now we should set up the project in TouchDesigner. And first I will save the project to the same working folder, so we don't need to miss the paths. So all paths should be also relative. So render glass. And here basically we don't have so much to do. We can read the files using file in. Then we just click here, find our working folder, go to Geo, read the glass. That will take a while because the geometry is heavy. I think sometimes we need to flip primitive faces to have the correct representation of geometry. Then we copy and paste that, and we replace it by metal frame. And in order to render, we have to bring that geometry inside of geometry object. So because in Houdini the data format is more strict, so we cannot basically create different type of operators in the same context. We don't see that problem, but in TouchDesigner you have to understand the difference. So basically right now in Houdini we have a glass object, geometry object, and inside that object the SOPs operator are living. In TouchDesigner we have SOPs and we need to bring them inside of objects. So objects are components, and first column are what is corresponding to Houdini objects. And here we have the geometry. If I just create a geometry, it doesn't have any inputs, and we have a shortcut. Instead of creating first geometry, we can click on the file out, then switch, it will automatically open on the SOP, then we can switch to the comp and create geometry, and this geometry will be created already connected. So let's call it glass. Then let's do the same for the second object. That will be frame. Then we need to create a shaders, materials, and we're going to use here the PBR materials. For that we need to create the special light, which is called environment light, and it uses the image based lighting. So we need to have the environment light map. And I go to my library of things and copy to the working folder, to the T folder, several textures. I go to my HOU2TOUCH course folder, and there in level 101, in lesson 10, in projects, I have a map, and I will copy that thing to here. Then I just drop it to TouchDesigner, and that is some environment map in equirectangular format, which is supported by the environment light. Okay, that is the first thing. Then I will need to create two PBR materials. And assign it here. And in order to render, I need to create the camera, and I need to create the render operator, which is existing in top context or in texture operators. So now we have everything quite black. So let's adjust it. And also what is very cool, that TouchDesigner supports the Substance Designer format, and we can use it for easy texturing, because Substance Designer Archive can contain textures for everything. So I will need to drag and drop here also the color, which I'm going to use for the glass. So I drop it here to the base color map. It's wrong. I have to drop it here. Yeah, and for the frame, I think for frame I don't need any textures right now, so we will remove it. Okay, now we might need to increase the dimmer of the light. Then let's set up a camera. So I will move the camera closer, so something like that. And then we can also rotate the light map. Before that, maybe we need to set up the material itself. So let's start with a glass material. I will reduce the roundness and it's already starting looking like a glass. I can reduce a bit the metallic part. Okay, maybe now I have too much of dimmer. Something like that. Looking already not so bad. Then I go to metal shader. I will reduce the roundness a bit. I will change the base color to something more colder and darker. Yeah, I like it. So let's save the project. Okay, what we need else? Maybe before we go to the interactive part, we also want to have some objects around. I go very fast with that because we're already working long, so I don't want to explode your brain too much. Basically, we can do something like using the same tube, or just copy and paste the tube. Then I will make a box. Let's make this box small by the Z-axis and make it bigger. Then that tube should have bigger weight. Then I want to divide this box to make it more consistent topology. And I can make a breaker polygon and reduce the size to something very small. Then I can use a Boolean object to subtract tube from the box. So basically we have that cutted geometry. Then we can use a delete operator and delete by rule. So actually I don't need a box. I created a box only for Boolean. And now I can delete by the normal direction. And we have a Z-axis, so I want to delete all polygons which are okay, do I have polygon? Yeah. So I want to delete all polygons which are above this spread angle. So I have only one flat surface. Now I want to remesh this thing to make it more random topology. So using remesh, I can create something like that. So let's make more iterations, more smoothing, and smaller size. So it will create very cool looking triangulated geometry. Now what I want to generate the stones on this surface, and I use the similar technique because I want to control the size of the stones. I will use the similar technique which we were using with attribute transfer. So for that I will make the tube with more details, and then I just create a new attribute by attribute create. I will call this attribute density, and I copy and paste that to the tube and set density to 0.5 or 8, something like that. Then I do the attribute transfer. Last time we were using the color, so now we use the attribute which is not visible by default. So I'm going to transfer density. How I can see the density in viewport? For that, I can open the display info and click on the density, and that will visualize density for me. So now I'm going to change the conditions. So now you can see already how density is going around, and now I can make a smoothing. Maybe I remove a bit the full density and increase the smoothness even more. So now we have a smooth gradient of density. We can create also attribute noise to add a bit of randomness to that float density attribute. So I will select the density from here, and I will add small amplitude of noise, and we'll play with element size. And now I can use the PolyReduce, again what we've seen already, but that PolyReduce have a very cool option. It can use for poly reduction, so basically I can just PolyReduce, and I can control the density, retain density by attribute, and then I just select the density parameter, and then I can control the weight of the density. And as you can see, that the size of triangles started to be controlled by that attribute. So I can even play a bit by increasing the remesh settings, so I can make it even smaller, denser. Also, I want not to touch by PolyReduce the borders. For that, I can create the special group of border points. That is easy to make by the group, because in group we have edges. I disable a base group, I create group by edges, and here I just select the unshared edges. So now we have 812 points in that border, let's call it border group. And now in PolyReduce settings we can come back and use that group as a, okay, we cannot use it because it's supposed to be the wait a second. Yeah, it should be available. Hard points. it's primitive group. I have to switch to the point group. Okay, yeah. So it point group border contains 812 points, and now I can bring these points to be hard. After that, that points on the edges will be not touched. And next, very cheap but super fancy trick, that inside of divide SOP, and actually that option is also existing in TouchDesigner, we can enable the option called compute dual, which makes something looking like that. It produces the very interesting thing, which looks like a bit like Voronoi, but it's not triangles. I want now to smooth and a bit edit every with polygons separately. That will be the source of my stones. And for that I use a facet chop. We're still using the very small amount of operators, which can provide so much of possibilities you cannot imagine. So I go and say unique points. That will automatically split that polygons to be separated shells, so they are not connected anymore. And now all operations which I will do on the polygons will be happening on every polygon separately. So I can make resample, which is just insert points on every edge. Resample to increase the amount of details. So now it's reduced amount of details, but I want to increase because the length of step is too high. So I will make it something like that, and now you can see it started to be like angles between. And next thing, I will just blur the point position using the attribute blur. And here I just increase the blurring iterations. And I will unpin the border points. And that will create something like that. Very smooth and very nice. I think we can easily delete the small things. So I will create again the measure tool, and I show you the second way how we can deal with that. We can directly use delete and generate group by expression in the group parameter of delete by writing the add area is less than 0.01. Okay, it's too much. So something like that. So we have a bunch of stones. Okay. And now we just need to generate the extrusion and smooth. But what I want to make it looking even more interesting, I want to fit the area to some range of extrusion distance. So basically, if we look into geometry spreadsheet, we can see that in primitives we have an area which starts from 0.01 and going until 0.027. So let me make the attribute VOP. VOP, primitive VOP in that case. And I will import primitive attribute from the first input. It will be float attribute and it's called area. Then I will use the fit range operator, which will just fit the range. So we take the original attribute, we will fit that from, and let's just create the parameters for that. So we will create the parameter, create input parameters. Then the result, we want also to add to this result a bit of noise. So we will use the primitive number, primitive, the ID, I think, no, prim num, yeah, we will use that. So let's make int integer to float, and then we just use the noise. Let's make any kind of noise. Let's connect that to the position, and let's promote the amplitude and frequency, and let's add that results together. So we generate the different amount of offsets for extrusion, and let's create a new attribute that we can do by bind expert. And here we need to call the new primitive attribute, and for that we can use the name which is existing in PolyExtrude already. So if I will create a PolyExtrude and go to the local control, I will find the distance scale parameter. It's called Z scale. So I can use that name and generate the attribute with the proper name. And now what I do, basically what this Z scale is doing, it's multiplying the extrusion we created. It's multiplying the extrusion in parameter distance by the value of the attribute. So that way we can achieve with one extrusion the stones of different height. And now we just need to set that ranges properly. So we were seeing that the area is going from 0.01 until 0.02, let's say. So we set minimum value in 0.001 to range of 0.025, and let's make a smaller amplitude of noise so we can see that somehow, and let's invert it, so somehow like that. Now we can reduce the basic extrusion distance a bit. Then we can generate the front group. Then we can create a second PolyExtrude which will extrude only fronts. So for that we select the extrude front group and we make another small extrusion and we use inset, something like that. And now we can just apply subdivision to make all these guys more smooth. We can apply smoothness, which will relax the shape. Okay, maybe I can reduce a bit the resampling because it's too... Okay, no, that's just too much. I think I just created too huge distance on the input here. Maybe I will remesh it to make it less regular. Yeah, that looks much nicer. Then smooth. Then maybe a bit of attribute blur. That way we have created the stones, so we can create a UV texture for them as well. We can just project the texture by the Z-axis, and we can use the original. So let's find somewhere on the start we had just a flat thing which we can send to TouchDesigner for rendering, and then everything else will just belong for the stones. And here we create a UV texture as well. So that will be the, let's just copy our outs. That will be the stones. Stones. And that will be the just a background object. And let's render it. Save. Let's save the project, and we are cool. So we have all the background objects now. So now we can just go to our render, which is geo, and drop this BG out and stones out directly here. So we can set up the additional rendering part. So we will just create a geometry like we done before. Geometry that will be stones. And that will be the BG So now we just need to create a shader for, at least for stones. Background can be just black. And for that, I go to my library in my Dropbox and will find the Substance Designer archive. So I have materials, I have substance, and I will look for something like old concrete. And I copy that to our working folder so we can upload later everything for you. And now I just drop it in TouchDesigner so we can see how the Substance Designer archive is loaded. That format is super cool because it contains different channels, so it can shade all the PBR shader, including the base color, ambient occlusion, normal, roundness, metallic. And now it's even processed on GPU. We can set the resolution of it here. By default, all textures rendered in 256, but we can set it to 2000. And then we have a very detailed map, which we can just project on the surface by using the PBR shader. And PBR shader in maps has a substance top parameter, which will automatically kind of fill all of these maps. And then I drop it here. And then I will set up a bit the shader settings. So I don't think the stones should be too metallic. I think we might check if the direction of it looks very black now. So let's reduce roundness. Needs some normals. Yeah, that is a problem with rendering. Can happen because in order to render thing with normals, it needs to have the tangent attribute. And in TouchDesigner we have the attribute create, where we can generate compute normals and tangents. And after that it should be shaded correctly. So now still don't really understand why I don't see that. But let's go step by step. So basically what I want to achieve now, I want to okay, that's background geometry was too on front. So I will also create an additional PBR shader here for the background. And I will just make it very dark. And for the stones, I will reduce a bit the specular level. Increase the... Okay, let's make it something like that. So basically what I want to make now, we can move the thing a bit back as well, background as well. I wanted to create a god rays, and for that we need to know where on render we have only the glass. So basically we need to make a mask, and for that we should render the glass separately, but we don't want to pay a cost of separated rendering. And for that reason, in TouchDesigner we have a special object called RenderPath, which will attach to the same GPU rendering process. So I just need to drop the render, and then in RenderPath I can redefine several things. Don't know why we have the error here. I think it's just a bug. So I can, for example, only render one thing, which is glass. So I will redefine that. Then I can clear to camera color and to the depth buffer. So that way we can achieve the mask of the glass. Then we can create the radial blur, which is existing in the palette. In image filters we can find the radial blur. So let's make the rendering to be full HD, which is unfortunately only existing in the commercial version, but I have it, so I will restart. Don't know what is the problem with my rendering. Okay, very nice. No mistake anymore. So now I can connect it to the radial blur. And if I will set the center point to 0.5 on both axes, basically the blur will start from the middle, which corresponds to the position of camera. Then I just can increase the amount of samples and increase the strength, so we have that nice ray effect. Should need to overdo that. Then we just can composite on top of our image. So let's make add. Also, what we can do to increase the quality, we can directly after the render connect the SSAO. It's not super qualitative, but it still can add some cool feeling. So I will set it to the full resolution. I will remove the blur radius, reduce the surface avoid angle, increase the samples and sample direction, decrease the SSAO radius. Basically I can see that alone without the color. Something like that is looking not bad. Maybe I also will move my glass a bit back. That will be looking much cooler. So we have quite cool ambient occlusion. SSAO means screen space ambient occlusion. And now I just can combine it with color. So now I can add. So I will be adding the God rays to my rendered image, and it looks fancy enough. So basically I would say we are done with the rendering part more or less. we can logically add some post-processing effects like bloom. Just need to be a bit less intense with that, but it's cool. And we are more or less ready to start with the interactive part. So do you still have do you have questions? Okay, I think bloom is a bit too much. Okay, I think it's time to start with interactive part, and then you will see that actually to make complex things is actually not so complex. So I will make a bit of ordering here, so that will be LRC for light rendering camera. That will be the rendering. That will be the objects or scene. Cool. So we can even color that by different colors. And save the project. Okay, how can we get the interactive control here and what we actually want to make with that? Let's define our task, which is most important thing. So what I want to achieve here, I want also to check a bit the okay, we can increase the anti-aliasing a bit. I want to make two things. Thing number one, I want to make the camera position react on my head position. So for that I think now I can easily remove the layer with my head from the stream and add it here. So I will use video device in, and here you can see my head. Okay, I will align my camera a bit. So let's stay in low resolution, and we can use the FaceTracker. So here I need to make some small announcement for the Mac users. I'm going to use a FaceTracker, which is also linked on NVIDIA. But even on Mac, we can create a custom scripts using MediaPipe, for example, which can be processed on CPU, and it's relatively fast. So basically, it's solvable. But anyway, for my experience, I also use Mac for music. I also have a TouchDesigner installed on Mac for some operations, but basically, logically, Windows for graphics is the only choice. You fairly to say Mac is not created for that. Okay, anyway, I can drop my camera. Fairly to say, before I will do something with that, I will put some NVIDIA denoiser to increase a bit the smoothness of the picture. And I also will reduce the resolution. Maybe even I will make some crop on the image, because we don't need the full the picture. So I will crop on both sides a bit, and top, bottom. Then I will fit that into image of 600 by 480 and use the resolution and reduce resolution on half. So that is more than enough for the FaceTracker. Then I drop the resulting image to the top. And what we can see here is basically the tracking data. So if I move on that side, you can see that box U parameter is going in direction to 1, and on that side it's going to direction of 0, and if I move my head up and down, we controlling the V parameter. So basically we should process U and V channels separately. So let's make that. I will select the U channel and just rename it to U. And then I'm going to select the V channel and rename it for V. Then what I want to say, all interactive work is basically just two basic rules. One rule, you have one input value in one range, let's say from -1 to 0.7, and you want to output that in the other range, which is, let's say, -0.5 to 0.5. So basically you can solve most of things by just fitting ranges. Other tasks are solved by analyzing triggers, which can invoke different events. So basically all two tasks left in our lesson is about that. We solve both typical interactive tasks you should solve in any kind of installation. So let's start with analyzing what we want to achieve. We know that if I move the head, so let's open that viewer here somewhere. If we move the head, we're going from 0.8 until 0.1, and we want basically to transform the camera by that. In order camera always look into center, we need to generate the target where the camera looks to. So I will make the null and drop it to the camera parameter called look at. So camera continue to look on that null, and now we can test. So if I move my head here, I want to see it from that side, let's say. And if I move that on that direction, I want to see it from the other side. That one thing I want to change. Maybe I will make my camera even a bit closer, so we don't have that holes on the background, and we can go a bit more. Okay, so we map from the range using mat chop. We can range, so if I move from here on that side, I will change the camera to the minus range. Okay, so that means from range from 0 to 1 will mean minus 0.7 to 0.7 on that side. Then let's analyze for the vertical. So basically, in that case, if I go up, it should rotate like that, and in opposite direction minus 4, 0.4 minus 4. So okay, that I set from minus 0.4 to the range of 0.4. And then I merge these things first. And then I rename. I want to save the information where I want to send this data in the name of the channel. We can do it by drag and drop, but I prefer that way because it makes things more controllable. So we know that our camera calls cam1, and it has two channels called TX and TY. So basically we can do it here by renaming it into cam1 colon T, then square parenthesis X and Y, which will automatically rename these channels in the proper naming. Then I will make a null, and in null, in order to use that names, I need to set the export method to be channel name is path parameter and click on the export flag. So now my installation start to work. And I can test, and if I'm not happy, I can increase the ranges or test how it will look if I invert that range. Depends on what I want. Second thing, which is not really reacting on my head position, is the center of the radial blur. So I want also to control it a bit. And for that, I should test. So if I go there, logically it should move on that direction. Something like 0.3. And we can actually add here the second mat and just set it from the range of 0 to 1. So we should use, let's just set it from 0 to 1 to the range of 0.2, 0.8. That will be for U, and the same for V. Then we can edit it later if we need. And let's merge them together. Let's rename and check the names here. So we use radial blur, and then let's center X and center Y. So we change here the pattern to radial blur, colon, center, and square parenthesis XY. Then we can use the same expert, we just need to merge these channels together. And now we can see that I obviously should change the direction of radial blur, so I will make it 0.8 on that side and 0.2 on that side. And also here, let's make it a bit less, 0.7, 0.3. So now everything starts to react properly on my rotation. Let's save the project, and it would be actually nice also to change a bit the environment map rotation, which is actually that parameter. So we can rotate it a bit by the y-axis on the on the horizontal rotation, and a bit on one of that angles on the vertical one. So I will copy the math again, and on horizontal it will be, let's say, 200 until 240, and on vertical it will be just minus 10 and 10. Then we merge these guys again together, but this time, yeah, this time we just change the naming. So then we rename, and we should rename to the environment 1. Then the name of parameter, we can look here. If I bring the mouse here, we can see that what is dropping down, and light map rotate. So I will write it here. Env light map rotate, and then I add square parentheses, and it will be YZ in that case. So now I bring that to export, and we have a full control over camera position, light God rays direction, and environment map transformation, which should somehow get a feeling of proper parallax effect. So, and the last part of the lesson, let's add some music here. So let's call that will be the video, and that will be the FaceTracker. Are you still alive? So, actually, I have the touch screen. That's monitor is touch screen. But in order to simplify things, I can use also the mouse. Let's sort it all nicely. What I want to tell here, TouchDesigner, and many people forget that on the first point is still the 3D program. And that is important not only because you might want to create some 3D graphics, and logically TouchDesigner rendering is a questioning, yeah, it's not the Unreal, so that you cannot create here super fancy photorealistic rendering. But the render top itself can return some information about the geometrical properties, and that's why we were in Houdini creating the parameter, the attribute, where we saved the information about the connection class of every glass shell that we will need to separate where we're clicking. And in order to receive this data about where we're clicking, we need to use the technique called RenderPick. So, RenderPick exists in two contexts, in chop context and in dot context. In chop context is much easier to set up. So what I'm going to make now, yeah, looks like and light map rotate. And yeah, I missed that point. So now it should work correctly. Yeah. And using the RenderPick, basically RenderPick needs a render top or render pass top. And if I just select the render pass here, which only has a glass, we don't need to struggle to separate which geometry we're clicking. So I drop that here. And now, second thing what that needs, we cannot interact with nodes. For the final project, for the final installation, we always interact with the components called container or something from the panel menu. That is a UI. So basically I can create a panel which is container, and I will set it up to be like 920 by 1080, and I will drop here the, okay, let me make another null on the end, so I can build in something if I need in between. So I go to panel, to look, and in background top I can just drop that null here to see what I'm clicking. Then I can open this panel, and if I click on geometry, okay, nothing happens because that RenderPick need to know now about this panel. So we have to bring that data, because by default it's linked to the project one, which is upper. So I drop that container here, And now if I start to click, that RenderPick returns the data about that I'm clicking. So if you can see, that is a trigger. So I can select this trigger channel if I want, and I can even put a trail. So if I click on different glasses, you can see that it's coming the trigger date. But we will use the trigger channel because we want, in that case, make sense to send data by the callback. That is a Python code. Basically, we can use just trigger and make things easier. But in order to be completely fancy and show the all possibilities in that short course and make it like that course really complete, I want to show a bit of the Python programming here. In order you, at least if you are scary about the programming, you can at least understand the workflow and understand what possibilities it brings. So then in that case, in that place, what I want to make, I want to generate the Midi nodes and send them to some DAW. I use Bitwig here, but on that place can be anything which can receive Midi nodes, even hardware synthesizers. I will not go now to use the TD Bitwig plugin, what we also have in TouchDesigner, which can give you very detailed and complex control on what is running in Bitwig, or use TD Ableton, which you can also use to control Ableton. But I want just to show how to send Midi nodes, and here the result. By the way, hearing the result will be a bit tricky because I sent now the music from TouchDesigner to to the stream, but let's see. Okay, first thing what we need to get, what is actually happens if I click. And also we need somehow to define in that RenderPick that we can separate the pieces, and for that we created the ID, I think that was ID attribute. So I can click on with middle mouse button on that geometry and see we have here the ID attribute. Cool. So I go to options, and here I can provide the ID attribute. What is cool, here you can fetch position, normal, color, texture UV coordinate, depth, instance ID, but because we don't use instances, we cannot use instance ID in that case, so we have to use the custom ID we create. Okay, now we have all the data, and we just want to print out to the text prompt, to the Python prompt, to text port, how the data is constructed. So basically we have a callback. Callback is a function which is automatically invoked by the event. Event is generated by the RenderPick, so we have that function which is done for us by derivative, and we have even some help here. So what we can see here, that we have some event. So let's print what is this event. So we can do it by debug event. And now if I click, TouchDesigner start to print out. And that's what we got. RenderPick event contains a lot of information returned, which we can use. So we can see that we have here the what is interesting for us. For us is interesting that we have select start and select end. So we have we can create node on select start and delete node on select end. Then I don't see my custom ID somehow. That's interesting. Okay, we don't need the object path, but okay, we can get this ID as a channel. Okay, so basically what we do, we should check if, so let's open the text port again. I deleted the debug. First thing we need to check if we starting the event or if we ending the event. So we can make it like that. If event, then we copy from here, select start is equal to twice equal means logical equal true, then we can send the nodes and do something. Okay, now we need to use something to send the nodes. For that we need to use the Midi out. Let's call it, let's define here the operator for that. That script. So I will call it just M is equal OP Midi out 1. Then we can capture the current state of RenderPick. So we can look into the ID and call it pitch. It will be the integer interpretation by the, okay, RenderPick op we already have here, so we don't need to write OP for that. We just make that, and then we ask for the channel called ID and return it as a float and convert to integer. And because we might have more pieces than 127, which is amount of nodes, I will write %127 to loop the values. Okay, that's all what we do now. Now we just need to send nodes. How we can know how we can send nodes? We should go to the Python help of the operator. And here we can find that Midi out chop class has a bunch of methods, and there is a method called send node on, and it takes a Midi channel, the index of node, which is number, and a value, which is not needed. So basically we just need to send channel and index. And for that we just do following thing. We write m send node on. We send on channel 1 and we send the pitch. Then if select event select end is true, we will send other message which is called set all nodes off. Because we anyway use a mouse now, we cannot send more nodes, so we don't have to care. And let's check the settings. We need to send the channel and the pitch value. So basically we send the same like here. Okay, now it should work. So if I will click, I have some mistakes. Line 28. Okay, sometimes it's working, sometimes not, because I think, let's reduce it by 126. Okay, next problem what we have, it sends could not communicate with Midi device, which is logical because we didn't set up the Midi device. And let's go and set up the Midi device. For that we have Midi device mapper. And we should create a new mapping. Then on Windows we can use the loop Midi driver, which corresponds to the traditional Mac OS settings for Midi. So I just install that loop Midi. Okay, I don't need to look to here. I just send out devices loop Midi port. Then I go to Bitwig, and in Midi settings of Bitwig I go to the controllers. Then I create a Midi monitor and set the input to loop Midi port. And here in the settings I set the Midi monitor to be input to the to that synthesizer. Then I will create another application. I can actually create now just the NDI output, make it stereo. Then I go to the TouchDesigner, which is still streaming our voice to the stream, and add audio VST. Audio NDI. Then I will create video NDI in and capture that VST output, drop it here. So basically then I can copy and paste that device, so we will hear that in stream. Why we need M? Because M is a object, that object Midi out, which is physically sending Midi nodes, and that is referenced here. So then yeah, do you need the M? Sorry, it's my mistake. Yeah, so now basically we can try if it's coming. I don't hear the sound anyway because I disconnected the sound, but it should come right now to the stream. I hope so. So I will check. I hope it's hearable. So now I save the project, and actually we are done with our lesson. Thank you for everyone who survived for this almost 4 hours lesson. Then maybe I need to make some additional information. As it was announced on our page, that workshop was just a part of the story, and it will be announced additionally, but anyway, I have to say about that. It will be 60th prompt by amazing community called Creative Code Art, who are our collaborative partners in doing what we're doing right now, and we will announce the creative prompt which you can use for create art. Then it will be some kind of poll about that, and we will give out 5 our basic courses. So we have TouchDesigner Extreme and Houdini Extreme. For everyone else who will not win the 5 free courses, it will be some discount. But I tried to make today lesson so wide used than possible. So my main target was that you understand that everything is doable. Then Houdini and TouchDesigner are not so crazy complicated, so you don't need to have a fear. Logically, it needs experience, but basically both TouchDesigner and Houdini are like a human language. So you just need to have the understanding of grammar rules and understand the words. All these things like exporting, connecting operators, etc., family of operators, it's like a grammar, and nodes itself are like rules, are like words. Logically, if you learn any language, you need to have a vocabulary which needs time. But basically, it's much easier than a human language. Only thing you need to have a basic logic, basic understanding of logic. That's all. So thank you for all participants. You really inspiring me. It's always, if you don't have real people sitting in front of you, it's quite heavy to hold this long time online, and having activity in the chat is always very important. You were active. That makes me happy. And I thrilled to see your works in our prompt. It was a funny thing because in our font we use for our website and promotion, that 60th became like a god. And we were joking yesterday with Isabel from the derivative company, which was in Berlin for the TouchDesigner Summit. That's the God prompt challenge. So it's like, I think the stained glass with a voice of angels is kind of God enough. So also, some of you might not receive some mails. It can happen, you know, because of like spam filters or kind of, I don't know, some problems with the mail server. So please check. If you will not find a mail and you want that, you can always write to Erin, to Creative Code Art Instagram, or to our HOU2TOUCH Instagram. So we are all accessible, and we will try to solve all communication problem by hand. Sorry if it was not so easy. The HOU2TOUCH Discord is not super active yet, but I think this workshop will be a punch for us to work with Discord more intensively. So I think that chat is not only for like today course, but it will be like live for future. And yeah, now I call the angels and thank you everyone.